Welcome back, students, to another video. This video now is going to be the solution to the practice set 1. Practice set 1. So please do this after lab 1, right? This is just to, once again, I want to stress that the practice sets are a way to reinforce the theoretical concepts that we learn in our labs, at least from the coding point of view. And more importantly, it's a way for you to try to visualize how I can create questions from the slides. But nevertheless, the practice sets, although they're very important, they're not exhaustive of all the material. Please make sure you understand all the material in the slides, because everything in the slides is fair game for the exam. So here I have my practice set 1 right here, and I have a little Excel sheet here to show you guys how I kind of sort of do these problems by hand, right? And if you're watching this video, please do the practice set first by pencil and paper, right? Don't even type it in R yet. Attempt to do it first yourself before you look at the solutions, or even if you type or before you even type the code in R, just so you can have a go at it, so your mind can get into the rhythm of trying to do problems like this. Max spend 30 to 40 minutes. I don't want you to kill your time on this. I just want this to be helpful. I mean, again, the point is to reinforce what you've learned, but at max 30, 40 minutes. It really helps if you try doing this yourself first and then look at the solutions, how it's done. So let me first go ahead and save this. All right, I'll call this PP1, ABI, PP1, answers. Alrighty, and here we go, number 1. Okay, so here we're creating a vector x. So x is going to be the vector. Again, and remember, guys, I always use the terms array and vector interchangeably. So when I say vector, I mean array. When I mean array, I mean vector. So this is what x will be. And now I have a new data container I'm creating called TOT, but TOT is going to be, looks like it is involving a lot of vector mathematics, all right? So let's do this step by step. Now remember, when you have a single equals, the data container is being created or it's being modified. The right side we always do first, right? The right side we do first. So here I will go ahead and type in TOT equals 10 times x. What is x, guys? X is the vector in number 2. So I'm going to go ahead and everywhere where there is x, I'm going to replace it with the vector just to make it easier. 1, 5, 6, 3, 2 minus 2 plus the vector 1, 5, 6, 3, 2. All right. There you go. Now, let's do some vector mathematics step by step, guys. So firstly, I will do 10 times this vector. All right, 10 times this vector will basically give me 10 times 1 is 10, 10 times 5 is 50, 10 times 6 is 60, 10 times 3 is 30, 10 times 2 is 20, right? So I'm left with this. From here, I'm going to now knock out this second part right here, which is 2 plus 1 plus 5, 6, 3, 2, etc., etc. So I can drop the parenthesis. I'm going to drop the parenthesis here, drop the parenthesis here, and let's go ahead and update this. 2 plus 1 is 3, 2 plus 5 is 7, 2 plus 6 is 8, 2 plus 3 is 5, 2 plus 2 is 4. Right? So now I have this nice little vector. And guys, check it out. All right, check it out. I now have a vector minus a vector. Did I explicitly show you guys what happens in this situation? It's just like your column mathematics. So in this situation, now it's not a number to a vector. It's now number by number. Why? They're equal sizes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So position 1 minus position 1, position 2 minus position 2, position 3 minus position 3, etc., etc., etc. That's how it works, right? So 10 minus 3 is going to be 7. 50 minus 7 is going to be 43. 60 minus 8 is going to be 52. 30 minus 5 will be 25. 20 minus 4 will be 16. All right, and so the final answer for TOT will be this vector, 7, 43, 52, 25, 16. All right, it's that simple, guys. It's that simple. Now, some of you guys might ask the question, all right, that worked out well because there was an equal distance, right? And for my BAP students, you're like, yeah, no problem, right? But now the question is, what if they were different lengths? And my BAP students will be like, no problem, it's an error. No, 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 not in R. And remember, I told you guys this last semester, not in R. R is flexible. R is flexible. Let me show you. So here is, I'll call this example, right? So here's an example. I'll call this example 1. I'll include this with the solution set just so you guys have it. Let's say we have a vector 2, 4. All right, sorry. Let me use the R syntax. All right, so we have vector 2, 4. And let's say we have another vector. All right, and now let's say we have the same situation where I say A plus B. All right, now in Python and NumPy, this would be an error. That's not the case here, guys. That's not the case here in R. Okay, when you have a situation where you have vectors or data containers of different sizes, what happens is R will simply repeat. This is what I mean. The answer to this will be 2 plus 10 is 12. 4 plus 20 is 24. And now we're out of numbers. The first vector, vector A, is out of numbers, but we have one more number in B. What happens? A will simply start repeating values. So then it becomes, we go back to 2, and it'll be 2 plus 30 to give us 32. And then it'll stop. Do you see? Whichever data container or vector is the smaller one, those values will keep repeating until the mathematics is done. That is how R handles this. Yes, you will see a warning. If you type this in R, you're going to see a warning, but you won't see an answer. You won't see an error, and you will get this answer. All right? So that is a major difference, again, between Python and R, guys. All right? Okay, number 2. What is X? This is literally from our, it's like our slide, right? So X is going to be really just straightforward. The first value is going to be 55. The second value is a function, 1 to 10 in steps of 2. So it's going to be 1, 3, 5, 7, 9. But it won't be 10, guys. Why won't it be 10? Because the next number after 9 is 11. So even though R is inclusive, there's not going to be a 10 here. It just totally skips it. Oops, sorry about this. It's quite annoying. All right, so we have 55, 1, 3, 5, 7, 9. And the next set of values will be just simply 2 and 4 and 5. All right, and there you go. That's the answer right there. Number 3, what is A going to be? So A is, we have a couple swaps going on. No problem. So A is, it looks like it's the same value as X, so I'm going to just cheat a little bit. Grab this. Start off with, this is A. So after line 1, we have an A vector that's these values, okay? Now in line 2, we are saying go to the second position and overwrite that to be 3. All right, go to the second position right here and overwrite that to be 3. So after line 2, then that'll be the vector. And in line 3, we're saying go to the 8th position and make that equal to 6. So 1, 2, 3. First, let me copy this. 1, 2, 3, 4, 5, 6, 7, 8. So the 8th value will now be 6. Boom. And that is the answer. For the exam, when you have problems like this, just give me the final answer. You don't have to show all the steps. Any way you can. It's on a response browser. But I just want to specify, just give me the final answer in that situation. All right, number 4. We got a for loop. All right, now we start off with a vector b. You guys know what 1 colon is, right? 1 colon 5 is going to be 1, 2, 3, 4, 5. T is going to be 0. And now we have a for loop. For I in b. So we're going to have a iterator variable I that's going to iterate in the vector b, 1, 2, 3, 4, 5. In this case, how many loops will we have, guys? We are going to have 5 loops. Loop 1, because we have 5 values in b. Loop 2, loop 3, loop 4, and loop 5. All right. In loop 1, when we started off, I, the iterator, will have the value 1, the first value in b. Now we can finally move to line 5. In line 5, I do t equals t plus b. All right. Now, let's simplify this. Remember, we do the right side first. What is t right now? If I look in line 25, t is 0. Nice. What is b? Look at line 24. b is a vector. b is a vector 1, 2, 3, 4, and 5. So t will simply, there's vector mathematics happening here, where t will simply become whatever 0 is plus 1, 2, 3, 4, 5. In this case, what is t going to be, guys? T is now going to be overwritten to be this vector 1, 2, 3, 4, 5. Doesn't matter what they were. This is now what they've become. That's just the reality. And now I go up here, and I will overwrite what t is. So after the first loop, this is what t has become. We're done with that iteration of the for loop. We move on. What is I now? I will be the second value in b, which is 2. All right, sounds good. Okay, t equals t plus b. All right, so just to skip a step. So what is t now, guys? Okay. In line 25, t is now a vector. 1, 2, 3, 4, 5. See that? That is what t is. And what is b? b is still a vector. 1, 2, 3, 4, 5. So now we have this vector math happening, a vector plus a vector. Again, a vector plus a vector, they're same dimensions. You guys know how this is going to roll. T is now going to be 1 plus 1 is 2. 2 plus 2 is 4. 3 plus 3 is 6. 4 plus 4 is 8. 5 plus 5 is 10. And now t equals this vector. So I'm going to copy this. And this will be now overwritten, guys, to this. We're done with that iteration. We go to loop 3. All right. Whatever, it's making a capital. T equals t plus b again, guys. T equals t plus b again. Again, t equals t plus b. What is t now? T is 2, 4, 6, 8, 10. You guys get the gist of what's happening now. And plus b, well, and this part you guys, sometimes you guys confuse that. What is plus b? Look at line 24. What is b? We've never changed b. So b is still going to be 1, 2, 3, 4, 5. All right. So what is t going to equal now, guys? we do the vector mathematics. 3, 2 plus 1 is 3. 4 plus 2 is 6. 6 plus 3 is 9. 8 plus 4 is 12. 10 plus 5 is 15. All right, same thing again. T is now overwritten to be this. And so on, so on, so on. So now I'm going to go ahead and just finish this off. Just move a little bit faster. Let me scroll over this over so you guys can see it better. Four, 8, 12, 16, and 20. All right, copy this. And finally, we're on loop 5, where I equals 5. And again, T will equal this plus BE, which is still never changed. 1, 2, 3, 4, 5. All right, and now T is going to be 4 plus 5, 10, 15, 20, 25. All right. So the loop is finally finished. At the end of the day, what is T going to be, guys? T is this answer right here. And let me just type that down here, just so there's no confusion. All right. Simple looking for loop, a lot of things going on. Number 5, let me move this in. All right, so number 5, I have another for loop. Yes, so check it out. I didn't show you guys the syntax before. B equals C parentheses. What happens in this situation? So basically what happens is you have a data container called B that's created, right? If you guys run this in R, you're going to see something like this, right? You're going to see something like this. There is a data container created, it's just there's nothing in it. It's like creating a bookshelf with no shelves, right? It's just a box, if you want to think about it, with no shelf in it. All right, now A is going to be 1, 2, 3, 4, 5. All right, and now we go to the for loop. Now for the iterator this time is X, and it's iterating through A. So again, we're going to have 5 loops. All right, and we start off with X equaling 1, first value in A. Now, here we have conditions. Now, we did this before, so I'll walk through this slightly faster. The first condition in line 6 must be checked. A of X, basically A of 1. What is A of 1? A of 1 is the value 1. Is 1 less than 3? Let me write that. Is 1 less than 3? Yes, it is. Therefore, we do line 8. And we don't do line 12. Lines 10 to 13 will not happen because in line 6, 1 is less than 3, which is true, which means we do lines 7 to 9. And that's it. Remember, if and else, you do one or the other. So this basically becomes B of 1. I'm going to simplify it as we do it. Equals A of 1 plus 3. Right? And again, A of 1 is 1. So B of 1 is going to equal 4. So I go here now, and in the first position of B, there's finally a value called 4. Excellent. We're done with the rest of the loop. We now go to X equals 2. All right, again, in line 6 is A, let me zoom in a little bit. Line 6. If A of 2 less than 3, A of 2 is 2, Yes, 2 is less than 3. So again, we do lines 7 to 9. So I'll just copy this. And this time I will change this to 2, 2, right? And now b of 2, guys, is going to equal 2 plus 3, which is 5. All right, and up here, I will go again and change the second position to be 5. Now, there's no second value there, so we just 5 just goes in there. Done. Now I do x equals 3. All right, and again, line 6, if a of 3 is less than 3, well, what a of 3 is 3. So is 3 less than 3? It is not. It is false. Therefore, we jump into the else. From line 10 to 13, we jump into there, and we now do b of 3 equals a of 3 minus 3. All right? This becomes b of 3 equals, remember a of 3 is 3. b of 3 is going to be 0, right? 3 minus 3. So here, in the third position, we put a 0. X equals 4. Is a of 4 less than 3? A of 4 is 4. 4 is not less than 3. Again, we jump down to this one. And this becomes b of 4 equals a of 4 minus 3. Remember, a of 4 again is simply, a of 4 is simply 4. So 4 minus 3 is going to give me 1. So now b of 4 is 1. Sorry, 1. And finally, x equals 5. A of 5 is a of 5 less than 3, line 6 again. A of 5 is 5. 5 is not less than 3. Again, we go down to the else. So it's basically going to be these guys again, where b of 5 equals a of 5. And remember, a of 5 is 5, so b of 5 is simply going to be 5 minus 3, which is 2. And so finally, the fifth value in b is 2. And the answer, the question, essentially the initial question was, what is b? This is what b is. And we are done there. All right, 6. Oh, all right, excellent. Looks like we did 6 already. 5 and 6 are the same questions. Apologize for that. All right, number 7. Number 7 is more vector mathematics. All right, a equals 2. That's easy. A is 2. B is 4. C is 3. But P is 1 colon 4, so P is going to be a vector. 1, 2, 3, 4. And now we have another equation again. E equals P times a to the power squared plus, by the way, this little symbol right here means to the power of, so a to the power of 2 plus p times b plus p times c minus 2. Now, I'm going to rewrite this, but I'm going to replace p with all its value. I'm going to replace the whole equation with their respective values. So E equals P, which again is 1, 2, 3, 4. Let me just copy this because I'll probably have to do this again. All right. Times A, which is 2, to the power of 2. All right. Plus P, again, times B, and remember B is 4, plus P times C, which is 3, minus 2. All right, so this is the equation we have. Member algebra, PEMDAS, is in effect. So we can simplify this a little bit again. 2 to the power of 2 is essentially 4 So this part and this part are essentially the same. And 3 minus 2 is essentially 1, so this just goes away over here. Excellent. All right, and now we can bang out our vector mathematics. So I'm going to do all 3 parts in one shot. 4 times 1 is 4, 8, 12, 16. And that's the same as this. 4, 8, 12, 16. Oops. All right. And now we just have 3 vectors we have to add up. You add up 3 vectors the same way you would add up 1 vector. I mean 2 vectors, guys. Just add the elements. So 4 plus 4 plus 1. 4 plus 4 plus 1 is going to give me 9. 8 plus 8 plus 10 gives me 18. 12 plus 12 plus 3 gives me 27. 16 plus 16 plus 4 gives me 36. All right, guys, real short and sweet. And this is our answer. What is the, oops. That's our answer right there. Number 8, what is C? Okay, so this is relatively, again, straightforward. B is going to be a vector 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. Now C is going to be, remember, don't confuse C data containers with the C function. 2 different things. You can have functions and data containers with the same name in R. R knows the difference. You shouldn't do it just from a logical, easy to read sort of point of view, but it's there. It happens. All right. So C is going to be what? C is going to be basically any element in B, right, that is both greater than 5 and, see that? And less than equal to 8. It has to, because we're using an and, it has to satisfy both conditions. So it has to be less than 5, greater than 5 and less than equal to 8. Let's go and find it. All right. So C is going to be, is 1 greater than 5? No. Is 2 greater than 5? No. Is 3 greater than 5? No. Is 4 greater than 5? Notice I'm just checking the first condition. Why? Because if it doesn't pass the first condition, I don't even have to check the second condition because both conditions must be true. Is 4 greater than 5? No. Is 5 greater than 5? No. Is 6 greater than 5? Yes. Ah, okay. 6 is greater than 5. And is 6 less than or equal to 8? It is. Boom. All right. Is 7 greater than 5? Yes. Is it less than or equal to 8? Why, yes, it is. Is 8 greater than 5? Yep. Is it less than or equal to 8? Yes, it is. Is 9 greater than 5? Of course. Is it less than or equal to 8? Nah. Is 10 greater than 5? Yes. Is it less than or equal to 8? No. So my answer is going to be 6, 7, 8. Now, guys, look. The order matters. The order matters, right? If I did this, here's a second example. Example 2. Let's say I had a vector B. Let me write the proper R syntax. That was like 10, 2, I don't know, 7, 1, 5, right? So that's something like this. And let's say I did C equals B. B is greater than 2, and B is less than going to less than equal to 8. All right, same. The less point. So this time, C will end up being what? Is 10 greater than 2? No. Is 2 greater than 2? No. Is 7 greater than 2? Yes. Is it less than equal to 8? Yes. Is 1 greater than 2? No. Is 5 greater than 2? Yes. Is it less than equal to 8? Yes. 5. So this was the answer would be. Notice it's still, even though it's a subset of the original array, it's still preserving the order of the values, no matter where they showed up. So I just wanted to stress that point, right? Order does matter. Order does matter. All right, number 9. Oh, I'm sorry. I did number 9, guys. I apologize. I did number 9. This is number 9. And now I'm going to do number 8. I'll just slide this down, guys. Apologies all around. This was number 9. I'm sure some of you guys are looking at the video and be like, "Yeah, about to send me emails." So let me just scoot this over and I'll do number 8 now right here. All right. Here's number 8. Got a little excited there. Now that we did number 9, number 8 is even easier. All right. B is this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And C again will be all the values of B that are less than 5. So 1 makes a cut, 2 makes a cut, 3 makes a cut, 4 makes a cut, and that's it. And so for 8, this is the answer. All right, so that's actually relatively easier. Let me scoot this over. Done. All right, so now we're on number 10. Looks like we have just 2 more to go, 10 and 11. So number 10, again, we have B equals 1 to 10. Excellent. So this is B. This is the power of doing. This is why I like doing Excel. I get to cheat. But you guys don't cheat. You guys do it the hard way. Unless you know how to program, then that's fine. All right, now look at what's happening. I'm using the sum function, right, on a B container. But in the B container, I'm selecting some of the values, not all the values, right? So look at how this is happening. X equals sum. Remember, when you see complexity like this, always go inside out. So here we have a sum function, but first we must go inside out, meaning let's select our new B values let's select our subset of B values that we're getting from the B vector. All right, what do I mean by this? So within here, the vector that I'm selecting is going to be from B, but in this order. I'm selecting the third value, which is 3. The second value, remember 3 colon 1 is 3, 2, 1, right? And notice these are being wrapped up into a C function. So this part right here creates a vector, right? This part right here creates a vector that's going to be 3, 2, 1, 5, and 8. That vector is being passed within the brackets of a data container. So when a vector is passed within the brackets of a data container, you are simply selecting multiple values from that data container with the positions being dictated by that vector. So here, all right, so when I go back down here in my Excel sheet, basically this amounts to the value 3 being selected, the value 2 being selected, the value 1 being selected, 5, the 5th value being selected, and the 8th value being selected. All right. And so it just so happens that the positions correlate with values. It just so happens. So the summation of all these values is going to be 6, 11, 19. So x will equal 19. All right, that'll be the answer. All right, now let's do example 3. Can't type for some reason. Example 3. Let's run this back, but this time let's say B was 10. Actually, let me do actually. Let's say this is B now. Okay, so now B is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's run back what we did number 10 and see what the answer will be. Now it'll be x equals, right? So over here, let me just type it all out so it's easy for me to count. 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. All right. So x equals sum, and the inside array or vector is going to be the third value of b. What's the third value of b, guys? It's 8 in this example. The second value is 9. The first value is 10. And now the fifth value is going to be 1, 2, 3, 4, 5, which is 6. And now the eighth value, 1, 2, 3, 4, 5, 6, 7, 8, is going to be 3. So in this example, right, we have the values 8, 9, 10, 6, 3. And in this example, x will equal 17, 27, 33, 36. All right? So you see how that works? Right? You see how that works? The positions tell you the values, and then you summate the values, right? It just so happened in number 10 we had 1 to 10, but in example 3 we had 10 to 1, and that totally changed everything up, right? So you just need to be on point about that. There's positions and then there's the values that are in those positions, right? And finally we get to number 11. All right, so number 11, B is 1, 2, 3, 4, 5. And now look at what's happening here. This is something a little bit different, right? This is something a little bit different. Let me type this out. All right, now, like I said before, when you have a single equals, do the right side first. Okay, so B3 colon 5, what is that essentially, guys? That is going to be a subvector of B of the values 1, 2, 3, 4, 5. Done. These values are going to go into these positions. Now, on the right side, we get the values of the equals. On the left side, we are selecting where those values will go. Now, the problem here lies in the problem here lies that we have 3 values, but we only have 2 positions. So what's going to happen? Who remembers? It's like a bus. The bus comes with the positions, the seats. Doesn't matter how many people are waiting in line, only the first 2 are going to get a seat. So here now, if this is B, the original B, the first value, first position becomes 3. The fourth position, because remember, we're using a C parentheses, we're choosing the first and the fourth location. The fourth location remains 4. There's no more positions. 5 doesn't get on the bus. That's it. It just ends right there, guys. So B ends up being this value right here. Okay? Now, this is different, and let's goes to example 4. This is going to be different if I did B equal, oh, I'm sorry, we're not done. All right, I'm sorry, I jumped the gun. So for number 11, so this is B, and now we do x equals sum of B. All right, so x equals sum of B. So x is going to be basically 3 plus 2 is 5, 8, 12, 17. Right, so this is the answer. All right, now let's run the problem in 11 again. But this time I'm going to say, okay, B equals 1 colon 5. All right. But this time I'm going to say B equals, sorry, B3, I'm going to switch it. B3 colon 5 is going to equal BC1 comma 4. All right. Now what happens? Once again, we go with the right side first, guys. In the right side, I have the subvectors. The first position of B is 1. Oops. The fourth position of B has the value 4. So I have something like this. But now, guys, right, on my left side, I have 3 positions available, but there's only 4 values. So again, my BAP students, you'll be like, oh, no problem. This is an error. Not in BAP it is. No, I'm sorry, in Python it is. NumPy, not in R. R will give you a warning, but it will give you an answer. And this is the answer. The third position, right here, becomes 1. The fourth position stays 4. But the fifth position now, see, when the bus comes in R, every seat must be filled. So in this case, the fifth position, what do we put there? If you guys remember from the vector mathematics of 2 different size containers, the smaller vector will repeat. So now we did 1, we did 4, we did 1 right here, we did 4. Now we're going to repeat back to 1. And so the fifth position now gets the value 1. And now x in this case will simply be 9. You guys see that? That is the flexibility of R, which some of you will hate because in NumPy is easy. You just call the error and call it a day. But you guys will get used to this flexibility. I actually kind of enjoy it because it just allows me to be a little more creative with my code, have a little more flexibility in what I want to do and when I want to do it. So this concludes practice set 1. All right, it's pretty quick. And remember, please, hopefully you guys gave it a go before you guys looked at the solutions. All right, so I'll see you guys now at either at the next video or the next Q&A session. All right, have a good day, guys.